Okay, in this video I'm going to try to control electronic expansion valve using motor bridge and microcontroller. If you are not familiar with expansion valve, so you can check video on link below. The concept is we have here valve it will be connected to a motor bridge and this is H bridge. Okay, and from motor bridge it will be connected to microcontroller. Okay, so this is the basic schematic, and the position of valve will be controlled by temperature sensor. So when the temperature is high, the valve will be open. The more temperature is available, the more expansion valve will be open. When the temperature decrease, the valve is going to close. When the temperature increase, the valve is going to open. So this is the concept. So the valve position will be based on the input from temperature sensor. Okay, so this is expansion valve. Okay, and we are going to use motor bridge. This is 298, I believe, and we are going to use temperature sensor and microcontroller. I have now Arduino Mega. Okay, and this is external power supply socket. So in this video, to power up motor bridge, I have to use external power supply. Okay, so that's it. This is the materials. Okay, let's start wiring up. Before you wiring up, you have to know the pin assignment here. Okay, so here there are 4 pins. So let's check with multimeter. Now put multimeter in ohm meter, in ohm position. Okay, and we are going to check the coil. So let's see here. Okay, 51.4, and downside 51.2, meaning between this point and this point is in one coil. So downside, this point and this point is another coil. So let's see between coil, is it connected together or no? No. Also here, still no. So in order using motor bridge, so we have to consider this coil as one motor. This is motor A, motor B. Okay. So once you know the pin assignment, let's draw it here. The pin assignment will be like this. Okay, so one, two, three, four. Okay, 1 and 2, this is one coil, so consider as motor 1. 1 and 2, this is motor B. Motor A. 3 and 4, this is motor B. Okay, so let's wiring up. It will be like this. So I will use yellow and green for motor A. Yellow and green motor A. Okay. And blue and purple will be motor B. Okay. Okay, now let's connect to motor bridge. Remember, this is motor A and this is motor B. So you have here out 1, out 2, out 3, and out 4. Okay, remember here 1 and 2, this is yellow and green. So let's connect yellow and green in out 1 and out 2 respectively. So yellow is out 1, yellow out 1, green out 2. Okay, yellow, green out 2. Okay, purple out 3 is wrong. and blue one out 4. Okay, now let's prepare for power supply. We are going to use DC power supply 12 volts. Okay. Here there are 3 terminals: 12 volt, ground, and 5 volt. We are going to use only 12 volt and ground terminals. Okay, so let's use blue for negative, and brown for positive. Okay, so brown, we need to connect 12 volt. Here 12 volt. Okay, and blue, this is for ground. So let's prepare also another ground wire to connect ground of motor bridge and ground of microcontroller. So let's connect together. Okay, for power supply is connected. You have brown for 12 volt and blue and green, this is for ground, and this green wire has to be connected to microcontroller ground. Okay, now let's prepare for control signal. So here there are 4 wires. So in this bridge there are 4 inputs: input 1, 2, 3, 4. Okay, so let's connect this wire to terminal. Okay, this 4 wire to be connected to microcontroller. Now let's connect to Arduino Mega. Here I'm going to use input 1 up to 4 it will be connected to pin number 8 to 11. Okay, so let's see where is number input 1, blue, purple, gray, white, blue, purple, gray, white, blue, purple, gray, white. Okay, so okay, it's 8, 9, 10, 11. So it will be like this: 8, 9, 10, 11. Okay, and connect ground wire to any ground of Arduino Mega. I would prefer to connect here. This is the ground terminal. Okay, okay, now we are going to install a temperature sensor. I'm using DS18B20, okay, from Dallas Sensor. It has 3 pins. Okay, it will be like this. Just connect as easy as it is, but you have to remember the pin description. Yellow one is minus. We are going to connect this minus to the ground, and blue one is the signal output. It will be connected to Arduino input. In this case, I'm going to use pin number 2, and the middle one is power supply. We are going to use 5-volt supply by Arduino. Okay, so let's connect. Yellow is ground and green is 5-volt. 5-volt here. This is ground, yellow ground, and green 5-volt. Okay, and for the signal, I'm going to use pin number 2. This is 0, 1, 2. So it will be like this. Okay, so next we are going to program this Arduino. We are going to upload the sketch, okay, using this cable. Connect console cable to Arduino. Okay, and another end connect to USB port of computer. Okay, now select the port Arduino Mega COM20. Okay, and upload the sketch. Okay, done uploading. Now the program is already uploaded, so let's adjust the position in a way we can monitor the valve movement. So here is better in this way. Okay, I think this one is okay. Okay, once the position is fixed and you can see the piston, we are going to power up H-bridge module. Okay, after that we are going to energize Arduino Mega, then we can check in serial monitor. Okay, zero setting in progress. The valve is moving to maximum direction, which is 100% fully open. Then it will return back to 0%, meaning fully closed. And it will move based on the temperature sensor value. Okay, now start reading temperature sensor. Now temperature sensor is 79.14 Fahrenheit and the valve position is 14% open. Okay, so I'm going to increase the temperature by exposing soldering iron to the sensor, and you will see as temperature value increase, the valve position will be moving. Currently temperature value is 80.04 Fahrenheit and the valve is 16% open. So I will try to increase the temperature. Now temperature is increasing. The valve is moving now to 40%. 50% open. 57. Okay. Now it's reached to 90% open. Now I keep my soldering iron away and the pressure will be temperature will be down gradually and the valve will be closing slowly. Okay. Now the valve position is 57. Now 50%. (47). Temperature is 92 Fahrenheit. Temperature still 42. Temperature still 90 Fahrenheit, and the valve position is 40% open. The valve position 35% open. Valve position 33 open, 33% open. Temperature is 87. Now 30% open. Okay, still 30%. And temperature value is 86. Okay, now temperature value is 82 Fahrenheit, and valve position is 21% open. We are going to simulate again by exposing temperature sensor to heat source and see the movement. Okay, so I'm going to use this soldering iron and see the value on serial monitor. Currently 23 open, 22% open, and temperature reading 83. So I will try to increase it. Temperature is increasing, 94, and valve is moving to 61, 64, 66. Okay, now valve is fully open. and wait. Once the temperatures gradually decrease, the valve also will be gradually moving to close. Okay, now temperature is 86 Fahrenheit and the valve position 30% open. Okay, thank you.